Let's look at some ways how you can present statistical data. Now we have here quartiles. This is a way of dividing the data that you have. Suppose, for example, you have a large amount of information, and let's say you have, let me type them. So for example, 100. It could be other numbers, but I just use 100 to make it simpler in this example. And you're going from 0 to 100. Alright? Halfway up would of course be 50. But then quarter way up, which is halfway between 0 and 50, that would be 25, and then halfway between 50 and 100, which is 3/4 of the way up, would be 75. So these actually are representing percent because it's per 100 out of 100. Now, as I said, it could be any other number. It could be from 0 to 300. It could even be from 50 to 100, 50 to 200, and so on and so forth. Alright? But you actually have 3 divisions here. Between 0 and 100 you have 1, 2, and 3. Now at 25% of the data, you call that Q1. That's quarter 1, which is the first quarter. Then at 50% you have Q2, second quarter, and at 75% you have Q3. Now these are called quartiles. Now remember, you have 4 different parts. 1, 2, 3, 4. When you talk about quarter, you're talking about 1/4. Alright? But you have 3 dividing lines here. Between the lowest and highest, 0 and 100, you have 3 dividing lines. You call this the first quartile, second quartile, and the third quartile. So the first quartile is just about 25% or a quarter of the information of the values. The second quartile is halfway, 50%, and the third quartile is 3/4, 75%. What happens here is that most of the distribution will be between Q1 and Q3, and it could very well be that the numbers below 25% and the numbers above 75% are very small. So you concentrate on the numbers between 25 and 75%. Alright? It's like you have a test or some final examination given to thousands of students. It's not too hard, it's not too easy, and you therefore will find that the vast majority of students will get between 25 and 75%. Only very few will get below 25%, and very few get above 75%. So you're concentrating on the numbers between 25 and 75%. So you have Q1, Q2, Q3. So these are the 3 quartiles that you're talking about here when you say quartiles. Alright? Now, as for pictograms, in that case, what we have is a situation where you use pictures to represent data. One advantage is that persons find it easier, or they will tend to remember things easier if there are pictures or drawings associated with it. Alright? Now, I found an excellent website here that gives an overall view of pictograms. So let's take a look at that. It's vengage.com/blog/pictogram. So here, the pictogram is where you stack icons, or it could be real pictures or some drawings or something that looks like the things you're talking about. Right? And you stack them so that one of those icons might represent 10, it might represent 1 or 5 or 10 or 100, whatever it is. Now, let's look at a few examples. Here, it says, well, this is example from 2016. By 2016, 60% of people in the world had never received a phone call in their life. Now, some people will remember this figure, but if you associate some icons with it, you have the telephone, and then you have these head and shoulders that look like persons. The people you're presenting the information to would be more likely to remember the data from seeing these pictures, right? Well, after all, it's said in history, from thousands of years ago, before we had language, we remembered things based on what we saw, right? Even before we were able to speak to each other or to write down things. So we have a tendency to remember things better when we see images or pictures. Here, say 8 out of 10 people say they lack life skills. Their life lack an overall goal, I should say. So here you have icons, drawings, or some cartoon characters representing people. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. Only 2 of them actually made up their minds or are working towards a goal. This icon here seems to be a key for a house, and this one here seems to be a truck. Maybe this person has a goal of purchasing or building a house. This person has a goal of buying this truck. But the others, you see the question signs, they're wondering what they should set as their goals. They haven't set a specific goal as yet. So it's quite easier, much easier to remember these things due to the images. The person scratching their head and the question signs, alright? So this is another pictogram. Picture from pictures, and it's a pictogram. You have these stars. That's another form of a pictogram. So you have to have a number of items, and then some are shaded, some are not shaded, or it could be some are bright colors, some are, the others are dark colors that represent 2 different, or it could be more, but here 2 different categories of data. All right. Let's look at another one here. You have various roles in an organization, and you have colors. Can't be using too many colors though, but these colors and the number of icons represent the number of people, the relative numbers of people. All right, teachers, marketers, designers, students, and other. So you can see the vast majority of them are teachers, and then you have marketers. The category for other is the smallest category here. Here you have icons representing dogs. 1, 2, 3, 1, 2, 3, 4, 5, 6, 3, 6, 18. There's a total of 18 of them. So you might say, this might represent, for example, the proportion of dogs in a certain town of pets, not necessarily dogs, the proportion of pets that have received a particular medicine from the veterinarian, and this would be half of them. All right, so it's another pictogram. All right, now we have other methods of representing data. Now remember, in other videos I go into detail in actually drawing these using pencil, graph paper, virtual graph papers, and so on. I go into detail, but these can also be drawn by the computer. You have the bar graph, histogram, pie chart, and the line graph. The bar graph, it looks like bars, right? You have the burglar bar you put on your house for security reasons, or you might have the police put you behind bars. When police arrest someone, they say that they have been put behind bars, because traditionally these are there are these metal bars that the prisoner can look through. So they say that the person is behind bars. All right. So the bars might be horizontal, no, vertical in this case. The vast majority of bar charts are vertical, and you have others that are horizontal. All right. The histogram is somewhat related to the bar graph, but the histogram represents continuous data. There's no breaks, so you have to join the bars. With the bar graph representing discrete data, the bars don't have to be joined. But with the histogram, where one ends, the other starts immediately. You have the pie chart and the line graph. All right, let's look at an example of using a software to generate some of these charts. Now, you can use Microsoft Excel, but I'm not using Windows or Microsoft products here. I'm using Ubuntu, right? The Ubuntu distribution of Linux operating system, where I use LibreOffice Calc. It's an alternative to Microsoft Excel, but they have similar features. All right. Now, let's say, for example, you do a survey, and the survey covers method of transport, the method by which people are transported to work each morning. So you have method of transport, and you have the number of persons being transported by those methods. So you have, let's say, bus, how many people travel by bus. Let's say you found that 68 people travel by bus. Taxi, and 75 people travel by, say they travel by taxi. Private cars, or private transport. Let's say you might have 50 people. Motorcycles, you have 24 of them. Some live near enough to walk, So how many people walk to work? Only a few. 13. All right. Now let's highlight these and introduce a chart. Where is it? Insert chart. All right. So here, what we have is a bar chart. You see the bars? All right. In fact, let me just highlight method of transport and number of as well, and insert. All right, so these are the method of transport on the horizontal axis here, vertical axis, number of. So you can see here, let me move this chart. Not able to move it yet. You have a bar chart showing columns. It's a vertical bar chart. You see that here. Bus goes up close to 70, is 68. Taxi 75. Private motor vehicles 50. So you can see the chart reflects what the information in the table is showing. All right. It may be a vertical or horizontal bar chart as well. You may show a horizontal bar chart. Now you can make it have a 3D look. Look 3 dimensions. Although interpretation of it by an audience might not be as accurate, even though it looks nice to have it in 3D, all right? The interpretation might not be as accurate as having 2D. It can be stacked, bar chart, percentage stacked. You have various things that you can do with it, all right? Now, you have the pie chart. It's a circle with the angles, the sector angles representing the relative number of each item. So in this case, you have bus, which is blue. So you have the legend here. Blue represents bus. Taxi. You can see taxi is the largest category just by looking. You can tell it very quickly. Private motor vehicles. And you have cycle and walk. Walk is the smallest. Cycle is just a little bit more than walk. Alright. Even though they call this a pie chart, well, in real life, in my experience, I'm more familiar with the pizza being cut this way. I sometimes call this a pizza chart, but you know, pie chart is the standard names for these charts. Using the software, you can make it have a 3D look 3 dimension, and you can have the sectors separate like that. All right. You can have them separated in 2D, 2 dimension, or 3 dimension like this. Make them look like a donut, all right, or exploded donut chart. So you have various ways of fancying up these charts. You have here what they call the area chart. The areas under the curve represents the data. You have the line. This is a line graph, right? And you can make the line look 3D. It's like this. So you have those ways that you can make it look. Now, here, you also have all sort of fancy ways that might be somewhat confusing to many persons that you may be presenting to. So you wouldn't want to really use many of these methods of presentation. Here, I didn't put a label in. Let me see, chart elements, label, method of transport. Methods of transport. I have my label at the top, and you can have a subtitle. What would I call this now? Survey done by me. When you finish, you see method of transport, survey done by me. And then you have your chart below it. Alright? So that's what you have there. I didn't save it. But that shows you the various methods by which you can present data. Now, as I said before, when it comes to drawing these things, it's important that you are able to draw them by hand, and also using paper and ruler and draw them accurately, and also to calculate the angles in the pie chart and draw it accurately using a protractor, ruler and pencil on paper. So I have that done in other videos, but this video was just to get an overall view of these methods of presentation of the data. Alright, so I'll see you in the next video.